So this is where we left off from last time. In real world problems, the domain and range need to make sense in the problem. Like if I was giving you a real world problem and it said that we were walking along, would my time be negative in that case? No. Would my distance traveled be negative in that case? No. And we've been dealing with this entire chapter. I just haven't said domain and range when we're attached to it. So when you're working with real world problems, you're still basically doing the exact same thing. You say, okay, I can't have a negative amount of paint. I can't have a negative amount of hours used where I'm painting or whatever. That's your domain and range. You just got to figure out which one's which. So in this problem, you have 3 quarts of paint to paint the trim on your house. A quart of paint covers 100 square feet. The function A of Q equals 100Q. That's just function notation right there. Don't get freaked out by that. Represents the area in square feet that Q quarts of paint cover. So they've told you all your variables already. They've given you the equation, which is really nice. There's not a whole lot more to do here. What domain and range are reasonable for the function? What is the graph of the function? So first of all, we need to know what variable goes with domain and what variable goes with range. Which variable is the independent variable here? The quarts. The more quarts I have, the more I can paint. Okay? If you look at the function, A of Q equals 100Q, function notation tells you automatically what the independent variable is. The thing in the parentheses right here is the independent variable. So that's Q. Q stands for quarts. So the independent variable is quarts, which means quarts goes with the domain. So what domain makes sense? How much can I paint? Can I paint 0 quarts? No. Can I paint more than 0 quarts? Yeah. How many quarts can I use? As many as I want. Can I paint with 28 quarts? Really? You only have 3 quarts. So can I paint as much as I want? You could say yes, as long as I'm between 0 and 3, right? Okay. So, and we've seen that sort of notation before. The number of quarts that I use has to be between 0 and 3. That's the domain. So the range is going to be fairly easy to calculate, actually. Once you have the domain, just take these 2 numbers that you have here and plug them in. If I use 0 quarts of paint, how much area did I paint? 0. So the range is going to be between 0 and, if I use all 3 quarts of paint, how much area did I cover? It's 100 per quart, so 300 total. That's your domain and range. I know it looks very strange to you. You've seen this sort of notation before, though. If that's an and statement sitting there, I have to be greater than 0 and I have to be less than 3. I have to be greater than 0 and I have to be less than 300. So it says, what are domain and range? We got it. What is a graph of the function? So we can do that. Where do I put my origin? We don't have any negative values, so the lower left corner is perfect. Which variable goes on the x-axis? The number of quarts. That's the independent variable, and that's the independent axis. So the number of quarts. Now what? The y-axis is the area painted. Now what? Scale. For my number of quarts, do I need to change my scale? Don't need to. So by ones is fine. 1, 2, 3. Down the road we probably will wind up changing that scale, but this is fine. How about the area painted? By 50? By 25? We got to make it to 300, right? So let's see. 25, 50, 75, 100, 25, 50, 75, 200, 25, 50, 75, 300. 25s actually works. So we'll go by 25s. And I'm going to mark hundreds. 2, 3, here's 100. 1, 2, 3, here's 200. 1, 2, 3, here's 300. All right, if I use 0 quarts of paint, how much area do I paint? 0. If I use 1 quart of paint, how much area do I paint? 100. And 2 quarts? 200. And 3 quarts? 300. There you go. So there's your graph of the function. Now, do I have to use exactly 1 quart or exactly 2 quarts? No. So would I leave this as dots or would I draw a line here? Draw a line. Now, will the line, when I draw it in, extend out here? No, it won't, because I don't have any negative paint. I also don't have any negative area. Will the line that I draw extend out this way for forever? Because we only have 3 quarts of paint. If we were unlimited amount of paint, then yeah, you would, but not in this case. So we're just going to draw in that segment that starts and stops on our graph, and that's it. So the bottom question here, what if you had 7 quarts of paint? What would the domain and range be now? Between 0 and 7, so let me write that down. I don't have room, so I'll write it up here. The domain would be 0 is less than or equal to Q is less than or equal to 7. And the range would be what? $700, because now you could go all the way to 700 square feet painted. Now the bottom question, why does it not make sense to have a domain values that are less than 0 or greater than 3? You can't have 0 quarts of paint. Can't have negative quarts of paint though. So we'll write can't have negative paint. And why does it not make sense to let the domain go greater than 3 in the original problem? Yeah, you only have 3 quarts of paint. So that's the domain and range. The domain is how much do you have that you can actually put into this function. The range is what do you get out of it based on what you put into it. Okay? The x values is the domain. The y values is the range. X is the independent variable, y is the dependent variable. Domain is inputs, range is outputs.